We Have Concerns is only made possible because of generous donations from our patrons. If you want to be one of those, if you want to help make the show possible and also get extra stuff like bonus episodes, monthly hangouts, other cool stuff, check out our Patreon, patreon.com/wehaveconcerns.
Yeah.
Babies. Don't have any.
Not gonna. This is We Have Concerns. Hi, Jeff Canada.
Hi, Anthony Carboni.
Hello, concerned citizens.
Oh, man. I got a story here. Ben Sawyer sent this to us.
Hey, Ben Sawyer.
Yeah.
Flint Mac.
Our old bud. I believe he sent this to wehaveconcernshow@gmail.com.
Wow.
And this is one I think you're going to dig. We have talked so much on the show about AI. AI, big topic in science, big frontier that we are learning about, and new breakthroughs are made.
Yeah,
seems like
new
every
and
week.
exciting ways to crash cars and make mistakes.
Win at ancient games of table.
Sure.
Yeah. But this is a paper. This is a story about a paper that was written that claims that basically the entire field of AI research is akin to alchemy.
Yeah.
It's
sure
alchemy. We don't fucking know anything.
No, we're
doing stuff. We're making things. We're turning that lead into gold.
We've talked about this before.
We don't know why.
We've talked about this before. The entire point of AI is you give the system as few parameters and lines of code as possible.
Right.
Because every rule you give that thing is a programmed rule and not artificial intelligence. Artificial intelligence is when the machine can figure out the rules for itself. So the problem is you put the minimum you think you need to put in.
Right.
The minimum data set, the minimum amount of instructions, the minimum amount of code to make the thing do the thing. And then you just see what it does.
But it's worse than that. This article talks about the fact that, the goal is to put the minimum amount in, but when you don't know which is the part that did it right, you just add layers and layers and layers of code to start fixing things and improving your results. And you get to a point where you're not exactly sure which part is actually doing it correctly.
Right.
So there are three problems in the world of AI that this article addresses. The first is do you
know when your internet's not working and your internet's not working and you've got a router and you've got your modem and then you've got like a Wi-Fi extender and then you've got like your TV and
it's the worst.
And your TV is hard plugged in.
Yeah.
And then you've got like your phone and you're just like, you're trying to figure out
the worst.
What's not working about the internet. It's like, okay, now unplug the extender, turn off the TV and then replug in but like with a computer brain. But with making a computer brain work. And the fucking Time Warner guy is just like, I'm doing something on my end. Well, what are you doing?
Yeah.
I sent a ping. What the fuck does that mean? You sent a ping. Just reset it. It'll work now. Half the time, I've worked in tech support.
Yeah.
Half the time it's just like, I don't know, I'm going to give you as many excuses as you need to reset this thing as many times as it takes.
Unplug it and plug it back in.
For shit to just randomly work.
Did it work? No. Unplug it and plug it back in.
But
it worked this time.
But now on the scale of computer brain.
Right. So here are the three issues that they talk about. The reproducibility problem, which is basically like this amazing AI beat this guy at Go.
Yeah.
Oh, really? How did it do it?
How and why?
Well, not only do we not know how it did it, we can't get it to win this way twice.
It
won this way.
It actually just lost to a cat. The cat was just batting Go pieces around.
Yeah.
And it lost. And it shouldn't have lost because actually the cat, by what it was doing, forfeited.
That's what's really the key to beating AlphaGo is just there are no rules.
Yeah, I don't know. And then it lost to a 6-year-old, and then it won to a master again. I don't know.
Yeah, so we can't reproduce a particular effect. So if it literally did this strategy this time, there's no way to tell it to do that strategy again because it's literally just doing something new every time it's learning, right? So we have that problem, reproducibility problem. It's hard to study things in science if you can't reproduce them.
Right.
Okay. The second is what's called the black box or interpretability problem, which is when something happens in there.
Yeah. You put something in, there's a question mark, and then something comes out.
Something happens in there. It was good. What happened was good.
Yeah, we did that. What did we do? Yeah. No, but what did we? Yes.
Don't look in the box.
Good work for us.
We have no idea what's in there.
If you look in the box, you destroy everything that happened in the box. Yeah, we're all familiar with that. Yeah.
So neither of those problems is even what we're talking about here with this alchemy problem. This paper posits that not only is there a black box in individual AI in the sense that we don't know what's happening in there at all, the entire industry of AI is essentially a black box, is basically alchemy, because the way in which these researchers go about their research is completely trial and error, and they learn nothing from each other because they can't explain to each other why what they're doing is working.
Hell yeah.
It's alchemy. Well, I mixed the tincture with the other tincture and poof, I made the lead into gold and worked this time.
So here,
was there a full moon out?
Here's my thing.
I guess there was.
This is why I think, that these sort of large corporations that are working on AI are making more headway, I think, than probably educational or like academic organizations and individual researchers.
Because they're results oriented. They don't care. Right?
Not only are they results oriented, but they have way more resources. So it's the sort of thing where like, well, we have this initial chunk of code and it did this. There are 18 things we can change. And from there, for each of those 18 things, there are 36 things we can change. Because of their like ability to deploy, like they can just be like, all right, well, let's get 80 bajillion servers running every permutation of this and then reporting it back. And then we'll go again from there. And they have like the teams and I mean, this is just me from the outside. I don't know anything about anything, but it feels like the ability to have that many resources and that much trackability and scalability because you have that many people, you have that many tools. It feels like they are the ones that are going to do this for good or for ill because they're the ones that are able to run that sort of thorough testing. Whereas like the rest of us are like that guy trying to reset his internet. Yeah. So like a researcher that's like, okay, I know there are like 87 different things that could be changed and I was changing some of them and you're just like working on your own.
Yeah.
Even with like code tracking things and like repos and things like that, it's hard to like track this stuff and understand what's happening.
Yeah. Well, the author of this paper, Ali Rahimi, he says that a lot of what's happening is that there'll be a core algorithm that the AI is working on. And then the way that they refine the output of the algorithm isn't to actually analyze whether the algorithm is good or not. They just layer on top of it things that refine the results better and better. So the AI gets better and better at doing things, but they don't ever know whether the algorithm itself is flawed.
Well, that's what I'm saying. Like that feels crazy to me.
Right.
Because especially if you're somebody like Google, who's got, your DeepMind and your AlphaGo and like all that stuff, why wouldn't you try changes to the core algorithm first if you have the time, the resources, and the people?
Because they don't know what about the algorithm is working well or what isn't.
But wouldn't you find that out? Wouldn't you find that out by changing the core algorithm faster than you would by changing layers of things on top of the algorithm?
Well, the way all of these tests are done is that they use a process called stochastic gradient descent, which is basically a fancy way of saying iteration. They just keep changing things on top of it and refine the results and change the results and go, okay, we'll go slightly to the left here, go slightly to the right here, go slightly to the left here, and constantly add layers on top to get a more refined result without ever going back to the core bottom of what everything is built on.
So then is the idea that after you add all these layers and layers and layers and layers of refinement, you then are supposed to take the core algorithm and the layers that you added until you got the right result, and then analyze each layer and figure out how to bring it back into the core algorithm?
Well, that's what Rahimi is suggesting. He says they should do something called sliced analysis, which is basically chop out chunks and see what changes. So you understand what chunk does what and how it affects the end result. So you get a more refined,
Jeff,
fewer and fewer fail states.
I'm a brilliant computer scientist.
You kind of got to the
I
heart
had
of it.
no idea.
Well, you're basically just using your default position,
You know
which
what
is
it is?
destroy it more.
Do you know what it is, Jeff?
Make it
An
break it.
AI algorithm is just like a country. You need a hotshot outsider who doesn't know anything about the process to come in and really shake things up and drain the swamp of artificial intelligence.
You need the programmer's equivalent of a guy in shades driving the convertible who doesn't care. Maybe he breaks down in that town. Maybe he breaks down near where the programmers are making the AI. His car, he thinks he can get it done in a couple of hours to get it fixed and get out of that programmer's town, but it actually is going to take a lot longer.
This guy's run a lot of cons, this guy.
Yeah.
He goes from town, he's a real slick talker. But here's the thing. As he works more with these researchers, he finds out he's made the biggest mistake a con man can make, Jeff.
Did he fall in love?
He fell in love with the algorithm, and he fell in love with his team.
Yeah. The entire team.
He fell in love with this small town.
Yeah.
Where their only export is computer science. Salt of the earth people that all they do, working class people that all they do is create artificial intelligence algorithms for high functioning computer systems. And a small town full of good country folk.
His devil may care attitude changed that algorithm, but you know what? That town changed him.
Yeah, and you know what that algorithm needed? That algorithm needed a little bit of hotshot spontaneity.
That's
right.
And
do you know what he needed? He needed a little bit of working class computer science.
Little down-home programmer's ethics. That's right. What he needed.
And he came in shades, Jeff. He left in Crocs.
Yeah.
And that's what's important.
That is the beautiful lesson we've all learned here. And
that man was me.
Oh, I didn't even notice
and
your
I'm
Crocs.
a wealthy billionaire in Crocs.
I didn't even notice those Crocs you were wearing.
And I am the reason that Uber crashed.
So basically, as they refine and try to reduce the number of fail states, they're getting more and more complexity that they don't even understand. And when other researchers are trying to learn from the successes of their colleagues, they're not able to express why things are working and why they aren't. It's fucking alchemy.
This seems to me like the sort of problems that I hear, not just in AI, but in all kinds of engineering. Like people I know that are coders, game designers, things like that. They're always
Wizards.
like, I came into this project 2 years in, and oh my God, we were using this code that this guy wrote and he was gone and we had just been building on it.
And nobody knew why it did what it did.
Nobody knows why it was doing the thing. And all I wanted to do was smash it down and start over because that would have been the best way to do it. But it's hard to convince them to do that. And this sounds like a problem that happens throughout all sorts of engineering, really. Yeah. It's just interesting to me that the people that are working on AI wouldn't also write a very basic AI that tries different AI algorithms across different servers. I don't know. And once again, I'm just a guy in shades who runs drifts and goes from town to town trying not to make any emotional connections. Yeah. But it feels to me like that would be the way to do it.
It does seem like that would turn this town upside down.
I don't know, man.
What that would do.
It just feels like dancing should be legal. You know what I'm saying?
Yeah, I hear you.
Dancing should be legal, and you should just be running multiple versions of this algorithm versus things on top of it.
Yeah.
I don't know.
Let the kids program.
Let the kids program, you weird dad of AI. Ray Kurzweil.
Yeah.
You drive into town, and the town is Mountain View.
Yeah.
And Ray Kurzweil's not letting any of the kids code.
But Ray Kurzweil's sexy daughter develops an interest in you. And you guys do that game of chicken with digital tractors.
Second act twist, Ray Kurzweil's daughter, obviously a robot.
Oh, yeah.
Ray Kurzweil does not have a human daughter in this
real
story.
Human daughter, no.
No. I think it's kind of fascinating to me that AI, the people making AI, are working on AI the same way that people are understanding AI.
It's crazy that we're making shit we don't understand, and we're just blithely running down that road.
But that feels to me like the only way we
driving tractors down that road, heading into each other.
But that feels to me like the only way you could. And once again, this is just like a dope from the outside. But this feels to me like the only way you could maybe create a thing that has to be able to think for itself is like, well, I don't know exactly why it thinks for itself.
Yeah.
Because I have to give it the least amount of whatever to let it think for itself.
Crazy, dude.
It's nuts. And, it doesn't make me feel any better about what AI is going to do when we eventually create it.
What it makes me feel is, honestly, there will be a time many years from now when people look back on this time the same way we look back on alchemists of like, it was crazy that they were just thought they could do this.
And we made a lot of we made a lot of progress because of them, but also what a bunch of fucking idiots.
Exactly.
Wow. AI, everybody. And now this is for you to figure out. Were we really hosting this, or was this one of our AI episodes?
Yeah.
Because there have been 13 AI episodes across our entire run.
And chances are they're the best episodes.
Chances are they are the best ones. What we want you to do, look back at your favorite episodes. Tell us which ones you think were hosted by the Jeff and Anthony AIs. Because there are 13 of them.
There are 13.
We'll let you know if you're correct. You can let us know on Twitter. I'm at @acarboni.
I'm at Jeff Canada.
And you can hashtag those definitely robots.